Alright, so something weird happened with my camera, but I'm going to explain what just happened here. So we're going to, hopefully you did this U-try, and I took the whole circle, the area of the whole circle, and I subtracted the inside of it, so I can just have the outer ring, the area of the outer ring, over the whole circle. And so once I did that, 3 squared and 2 squared, I was able to take away the pi, because that becomes just 1 when I factor those out. And then so I have 3 squared and 2 squared over 3 squared. So 9 minus 4 over 9. And my answer then is 5/9. I have a 5/9 chance of dropping into the outer ring and not the inner parts of this target circle. Alright, we have not too much to go here actually. Angle measure is next. Hopefully you'll see a theme here, that is, you take the piece that you're looking for, the target, and you put it over the total. And that's just kind of the way all of these go. So here is a circle. And we're going to draw some different angles here. So I'm going to draw an angle like this, and this is going to be 105 degrees. And then I'm going to do one here. This is 70 degrees. Right here is 50 degrees. Then I have a 90-degree angle here. And then what's left is 45 degrees. So this isn't totally drawn to scale, but this is what we've got. And we've got a pointer, and we spin that pointer around and it goes around and around, and then we're going to figure out some probability of where it might land. So we spin that pointer there, and we're going to calculate some probabilities here. So the way we're going to write this, we're going to write P. That means the probability that pointer will land on 45 degrees. Okay, so we're going to look at the probability that the pointer will land on 45 degrees. So a circle, if you were to add all of these degree measures up, you should end up with 360. So 360 degrees, that's my total. And then my target is 45 degrees. And so if I were to divide both of these by 45, I end up with 1 over 8. So I have a 1/8 chance, if I were to spin this pointer here, that it's going to land on 45 degrees. 1/8 chance. Let's do another one. So I'm going to find the probability that the pointer is going to land on 70 degrees, on 70 degrees or 90 degrees. Okay, took it up a little bit of a notch, not too hard. Alright, so 70 or 90. So all we do is, 70 is a target, and so is 90. So we add those together, 70 plus 90, all over the total, which is 130. So we have 70 plus 90 is 160 over 360. And then if we divide each of these by 10, then I end up with 16 over 36. Now each of these I can divide by 4, and I end up with 4/9. So I have a 4/9 chance of spinning this and landing on 70 or 90 degrees. Alright, you do this one. Find the probability that the pointer would land on 90 degrees. Remember to simplify your fraction. Alright, pause. Alright, let's see how you did. So I'm going to take my target, which is 90, put it over my total, which is 360. And then 90 goes into 364 times. 1/4 is my answer. How'd you do? You can't really tell me how you did because I'm recording this, but I hope you got it right. Now we're going to do 2 more examples here, and we're going to find the probability of landing in the shaded space. So we're going to do 2 here. Let's go. Let's draw a rectangle, and this rectangle is 4 units tall and 10 units wide. Inside this rectangle, I have a triangle. This is a right triangle, and it is 5 units by 3 units, and this is the shaded region. So I'm going to find the probability that I land in this shaded spot. If I was just to choose a point somewhere in this rectangle, I would end up in the shaded spot. So all I'm going to do is I'm going to take my target and I'm going to put it over my total. For this one, the total is easy, right? It's this big rectangle. The area of a rectangle is the length times the width, so 10 times 4. So I end up with 40 as my total. And now a triangle, the area of a triangle, triangle is 1/2 base times height. And so 3 times 5 is 15 over 2. So 15, 1/2 of 15, or 15 over 2, right? So that is 7.5, 7.5. So my probability of landing in this spot, the shaded region, is 7.5 over 40. We could put that in the calculator, and we can say 7.5 divided by 40 equals, we've got a 0.1875 chance of landing in there. Alright, let's do one more. So I have a circle, and I have another circle inside of that circle. And this is the center of the big circle right here. And the distance, the radius of this big circle is 6. And it just so happens that little circle in there, the diameter is 6. And that's the circle I'm interested in, finding the probability that I'm landing in the shaded region. So remember, the area of a circle is pi r squared. So all I'm going to do, I'm going to take the area of the shaded circle and the area of the not shaded circle, put the shaded one on top, the full one on the bottom, and I will be done. So half of my diameter is my radius for this little circle here. So half of 6 is 3. So pi times 3 squared over pi times 6 squared is going to get me my probability here. Pi over pi is 1. And so I end up with 3 squared, which is 9, over 6 squared, which is 36. Divide the top and the bottom both by 9. And I have 1/4. 1/4 probability of landing in that shaded area. And that is 13-3.